Physics is everywhere. Let's check it out.
Hey, how's it going?
Oh, hey Kyle. Thanks for picking me up in your car.
Yeah, no problem. In my car.
Oh, I'm just gonna put my seatbelt on since we're in a car.
Yes, a car.
Okay.
Well,
Well,
let's get going.
okay. So, what time does the game start, Kyle?
At 8.
Oh. Well, your GPS says we're gonna get there 10 minutes early.
Yeah, that's because it works by satellites.
Oh, that's how it works?
Yeah, it actually determines your position, and then it gives you directions. So like northeast, south, west.
Oh. So it uses physics?
Yeah, simple physics.
Oh, so like your distance, which is in physics.
Yes, exactly.
Physics?
Physics.
Let's go, Blue Jays!
You got a
Let's
drink?
go! Oh, thanks. I'm really thirsty.
Yeah, no problem.
You missed it. Chapman threw 105.1 miles an hour.
Isn't that like a new record for him or something?
Yeah, they caught it on the gun.
Oh, really? How did one of those work?
Well, the radar gun calculates the speed of the ball using physics.
Physics? Isn't that in our everyday life then?
Yep.
Wow.
Physics! Oh my god, physics!
Physics.
Ramps. Speed and acceleration.
Hey guys, Ian's working on an equation downstairs. Let's go check it out. Or at least I thought he was. Ian, what are you doing?
Oh.
Stop. Oh.
Hey Kyle, I'm just working on my equations.
Well, what equation is it?
It's the acceleration equation. A equals v2 minus v1 over t.
And what are you going to do with it now?
Well, I'm about to show you. Using the equation that we used earlier, we're going to figure out how fast the ball is going right before it hits the ground. You might think that's really hard to do, but we're going to use that simple equation. We know the acceleration, when we assume there's no air resistance, is 9.8 meters per second squared. We also know that v1 is going to be 0, velocity 1, because when I let go of the ball, it's not moving. Also, we're going to try and figure out the time so we can find out how fast the ball is going when it hits the ground. So this is the simple equation that we're going to use to try and figure out how fast the ball is going right before it hits the ground. We know that the acceleration in this problem is 9.8 meters per second because we assume no air resistance and gravity pulling towards the Earth is 9.8 meters per second squared. We also know that v1 is 0. We found the distance, but in this problem it's not important because it doesn't pertain to this equation. v2 is what we're trying to find, and we found the time to be 0.8 seconds. Then we used our simple equation and put in the things that we knew into the equation. So we put 9.8 meters per second squared in for acceleration. v2, we still don't know that, so we didn't change that. v1 we know is 0, and time we know is 0.8 seconds. Then we brought 0.8 seconds over with simple math and did 9.8 meters per second times 0.8 seconds equals v2. We found our answer to be 7.84 meters per second equals v2. That means that right before the ball hit the ground, it was moving at a speed of 7.84 meters per second. Ladies and gentlemen, we have a real treat for you this evening. Dr. Kyle Arjun!
Thanks everyone, thanks for having me here.
Thanks for coming, Dr. Arjun. You know, we brought you here, you know why. Everybody wants to know. Everyone's talking about it.
Yep.
It's a big question. What is the difference between speed and velocity?
This is a hard one to answer. Speed has no direction. Velocity has a direction.
Ladies and gentlemen, you heard it here first on this show, without a name yet. It's a great show. Speed, no direction. Velocity, direction, northeast, west, south. Ladies and gentlemen, that's the wrap. Kyle's walking at a speed of 1.0 meters per second. The only difference between that and velocity is that his velocity is 1.0 meters per second north. Ladies and gentlemen, one more time, welcome back Dr. Kyle Arjun.
Thanks for having me again.
Nice to have you back, Doctor. The first question we asked in part 1, that was a biggie. But this question might even be bigger. Everybody's dying to know, what is the difference between distance and displacement?
Well, distance includes every step you take to get to an endpoint, while it can have multiple directions. And displacement is directly from a reference point to an endpoint and only has one direction every time.
There you have it, ladies and gentlemen. Once again, you heard it here first on this show. Dr. Kyle Arjun. Distance is from when he starts to where he wants to finish. He knows he's taking 5 steps north, then turning east and taking 3 steps. Kinematics to find his displacement. He found it would only take him 6 steps northeast instead of 5 steps north and then 3 steps east using distance.
Hey class, today we're learning about physics. Why do you guys think physics is important? Timmy.
Because physics inspires young people and it's really, really fun.
That's correct. Anyone else have any answers? Timmy.
Physics is needed for technological advances.
Anyone else? Alright, Bear from Mr. Oh, Timmy.
It's important for other people's professions too, like chemists, engineers, computer scientists, and other physical and biomedical sciences.
Oh, well, that's also correct, but does anyone else have an answer? Stewie. Bug from Bug's Life. Anyone? Alright, well, I guess we're gonna start. Timmy!
It extends our understanding of things like the earth, agriculture, and astrophysics. Important subjects around the world. All of them.
I actually don't know how you know all this stuff. This is the first day of physics. But anyways, anyone else? Quickly? No? Timmy?
It helps people develop new instrumentation and techniques for things such as medical work.
Yes, that's also correct. Pretty much covered the unit, Timmy. Stewie, Bear, Bug's Life guy, anyone? Alright, well that's the end of class, so good job today everyone, especially Bear. Go home, Timmy. No.